I'm President Barack Obama.
Hello.
And this is ObaMATH.
Woo!
Brought to you by yaymath.org. Give it up!
Yay, math!
Yeah. Now, Michelle knows that I have a thing for trigonometry. One of my favorite rules is the law of sines. Can't break the law. This is a rule of law. And the law of sines is good for solving any type of triangle. Are you riveted? Don't sound too disinterested. So let's draw yourself a triangle. You'll notice that this triangle is not a right triangle. Law of sines, interestingly, can solve any triangle. Okay, so let's put in some things. Let's say A, B, and C. All right, those are angles A, B, and C. Now, oops! Oops! Lower voice. Man with authority. Little a, side little a, is across from big angle A.
Love this.
I
Yeah.
know this.
Side little b is across from angle B. And side little c is over here. Any questions so far? Okay. Now this is the law of sines. Does anyone recall it? I'll start you off. It's the sine of A over something.
Sign of little a.
Very close. Over little a, just little a. Remember, you always take sine of angles. Equals the sine of what?
Equals
Same relationship for the other sides and angles.
sin B
over
over B, and then sin C over C.
That's right. This simple rule helps you solve any triangle, not just right triangles. So suppose we're going to give you some information. Let's say we said angle A was, put in green, say this was 40 degrees, put that in there. And we got 80 over here, and we have 20 here. Okay. Now if it said solve the triangle, we're solving for
60 degrees.
Okay, good. So 60 is something that we'd be able to get because 80 plus 40 is 120, and then subtract. So this was 60 degrees. That's good. What are the only pieces remaining that we haven't solved?
C and A,
C
little
and
ones.
A. Yeah, the C and A canal. Well, C and O, but never mind. Close to my hood. Let's put it in. We need a ratio that we can solve. Namely, let's start with 80 degrees. What if we did, let's move this separate here, sine of 80 over what side? 20 over the side across equals. Now pick another pair that you wanted to solve.
40.
So what of 40?
Sine.
Sine of 40
We're in the
over
little a.
for little a.
Little A.
Over little a.
Legally.
Yeah. And now we cross multiply. Okay, so if we were to cross multiply,
How do you a sine 80?
a sine 80. Bravo, sir. A sine 80. A sine 80
Equals 20 sin 40.
equals 20 sine.
Can you 40? Can you simplify that?
No, good guess. This is sine 40 is its own thing,
Okay.
its own ratio, and then this is times 20. But we need to get a by itself by doing what to both sides?
Multiply. Dividing.
Dividing by what?
Sine.
Sine of what?
80.
Divide sine 80, right? The exact thing that we need to get rid of, we divide by. So if you look closely now, a equals 20 times sine 40 over sine 80. Can you get that on the calc?
Yep.
You got it.
Okay, 20 times sine 40 over sine 80. Watch your parentheses. Should be less than 20.
I got 13.
Yeah,
0.5.
13.5. Great. So
Point oh
A,
five.
0.05.
13.05.
Wait, what'd you get?
13.05.
Confirm?
Sine.
20 sine
Yep,
40?
got it.
Great. Okay, so put that in, 13.05. Now, the only thing remaining is to solve for C. Why don't we just do the setup, and then we don't necessarily need to go through and solve for C. Because we're going to do that a lot. Let's do the setup for solving for C. Sine of?
Sine of 60.
Sure. Over?
Over C.
C. Equals a ratio that we have, which is what?
40 over
Sine of what?
sine of
80.
B,
40?
Now look, if we did sine of 40, that would be over 13.05,
Yeah.
right?
Yeah.
What if we got that wrong though?
80.
So let's do the 80.
Got it.
oh, because 20 was given to us, right?
And 80 was given to us.
Yeah.
Yes.
So we
yes.
should do what was given to us.
You should do what's given. It's a good idea. Yeah.
Alright.
So sine of 80 over the side across from it is 20. Okay, that's the setup. You would cross multiply it and solve. Any questions on setup?
Should after all this said and done, should all the exterior angles equal 360?
All the interior? No, these are not exterior angles. These are sides.
Sides. Should they
This-
equal some certain length?
No, no. Their sides can be pretty much any length. As long
So
as-
if it was a 60-60-60 triangle,
Mm-hmm.
and if you found one side, you'd find all of them basically.
yeah, yeah. If it was equilateral, all sides are the same. All angles are the same.
Sweet.
That's right. Okay, so that was the setup. That's pretty much what Law of Sines is. Right? We're just going to do another case that is kind of quirky with it. We have a 3 and a 4. Okay. Now it turns out that Law of Sines has what's called the ambiguous case. Meaning, sometimes the triangles are quirky. The way you can tell it's an ambiguous case is as follows. If I gave you two sides and an angle not between them, SSA, do you agree this is two sides and an angle that's not between? See, angle C would be the angle between.
Yeah.
All right. If I gave you two sides and an angle not between, I could potentially create two different triangles with them. It's strange. If I gave you the 28 over here, like if I gave you two sticks, one was 3 inches and one was 4 inches, and I said the angle between them was locked at 28 degrees like this, do you agree that that's only one triangle?
Yeah.
Yeah.
It's only one triangle to create. If I give you, here's a 4, here's a 3, here, okay, how do I fashion them? You're like, okay, angle between 28, lock, one triangle. But if I said here's a 3 and here's a 4, but the angle over here is 28, outside the 3 and the 4, then potentially you could create multiple triangles with them. All right? And that's this case. Another way to look at it is if you reverse the letters. But we won't do that. This is the Oval Office. This is the Oval Office, and you know, we got to keep things clean, especially those. It's important. Hygiene.
Keep watching.
If you were to reverse these letters. Oh, yeah. Perfect time to drink water. Compliments of the Oval
I
Office.
still don't get it.
Donkey, guys, donkey.
Oh, I get it. now.
Yeah, okay. If you see this situation,
We're a little slow here.
It's the ambiguous case.
You should teach English.
yeah,
English next.
I look forward to it.
So it's the community property in English.
Yeah. So let's actually set up Law of Sines to solve this problem. What would you like to solve? First of all, we have a ratio already here, right? So
Yeah.
can I say sine of 28 over what?
Over 3.
3 equals sine of,
B,
sure, let's do B. Sine of B over
4.
4. Very nice. So now you agree that we're looking for angle B. Let's go ahead and cross multiply.
Love the butterfly method.
I love it. We got 3 sine B equals what times what?
4 sine 20.
4 sine 28. To get sine B by itself, we divide both sides
3
by.
sine.
Very good guess. No, sine B is its own thing, okay?
Oh, sine B. That's.
So
Wait,
let's just get the
what's
sine B
3?
divide by 3. That's right.
I'm sorry.
No need to apologize. When it comes to learning, it's all good.
It's good to be wrong. I got 0.625962.
Okay, very good. So goes. Let's give me 4 decimals. Go ahead. Point
0.6259.
59. All right.
Yeah.
Okay, and then we dot. Now here's what's cool. Remember, if we're searching for the angle, we have to do inverse trig. Do you recall that, Dylan?
Yes.
Remember that inverse trig to get the
Sine
angle?
negative.
Yes, so B, that's right. B equals inverse sine of this ratio. All right. So now let's get angle B. Angle B. Go ahead, put that in the calc. So you're gonna do like inverse sine of that ratio. So I would get the thing that you saw in the calculator, and then do second sine, second answer.
38.75.
38.75.
Yeah.
So let's make it like 39.
Do you want the exact answer, or do you want?
Let's make it 30. I want to round to make it easy for us.
Okay, so 39.
Let's go 39. Okay. I know I'm acknowledging that it's a round, so we'll go like that. All right. So that's that one. B is 39-ish degrees. So we could put 39 in. So tell you what, let's make a list here. We have angle A, angle B, angle C. And we have little a, little b, little c. So we have angle A is 28. We had angle B is 39, right? Mm-hmm. Can you get angle C now for us?
Yeah.
Yes, you can.
Mr. President,
Yes, sir.
why is it ABC and not ABC? Like, why isn't the A B? Why isn't the B where the C is and the C is where the B?
I could have listed them anywhere.
And the A is.
I could have listed them anywhere.
It
It's
wouldn't
just a
change
sketch.
anything?
It wouldn't change, yeah.
Alright.
Okay, what do you got, C?
Confirming.
100.
It should be.
Oh yeah. Oh my god.
Whatever that is minus 1.
Yeah, whatever that is, minus 180.
113.
113, thank you. And then we have side B is 3. Excuse me, side A is 3, side B is 4. And then we have here, this was 39, this was 113. And now we can get side C. Let's go ahead and get side C right now. Okay. Using given information, if we can, anyway.
Can you use SOHCAHTOA here?
No, because that's only for right triangles.
Oh yeah.
Okay? Hypotenuse. All right, so set up law of sines for us. Go ahead.
Law of sine.
Yeah, sine of,
Sine of C.
which we know.
Sine of.
You can do it.
We don't know. We don't know B.
We want that. No, we know B. We got it. We got 39 for B.
So sine C.
Sine of how many degrees?
113.
113. Over which side?
C.
Very good. Equals sine of.
Sine of.
Hopefully given information is the best.
28
Yes. Over.
over.
Trace.
A. Oh, over.
Which is?
3.
Very good. Comfortable with that? Okay, cross multiply and solve.
And I
Three
got
sine
5.8.
Cool, you cross multiplied the whole thing. So you did this 2 multiplied equals this 2 multiplied.
Yeah.
And then you divided both sides by sine 28. Is that what you
Yeah.
did? And you got 5 point what?
8.
5.8. And it makes sense. Yeah, it's the biggest side. Excellent. Now, this is going to be weird now. Get ready. Hold on.
Oh god.
Lord.
I know. Let's go to pray. Now, when you have this ambiguous case with SSA, I'm going to show you something. Is it possible that B could have been something else? That's the question.
Yee.
Okay, I'm going to show you what I mean by B being something else. Let's get this off. Take this. Here. Okay, back to our triangle. Let's say this was angle, this is some angle, and this is opposite over hypotenuse, right? The sine of this angle is positive opposite over, hypotenuse. Hypotenuse. There you go. This angle is positive opposite over positive hypotenuse. All right, this angle turned out to be 39 degrees. Does that make sense so far, so good?
That does indeed.
What if we drew this triangle, though, with 39 in quadrant 2? Would this line, first of all, would the triangle be a
109.
mirror image of each other?
Yeah.
We'll get to what the angle is.
just kidding.
Would the triangle be a mirror image of
Yeah.
itself?
Yeah.
So the lengths are the same.
Yeah.
So this is sort of the same O because it's positive,
Yeah.
and this is the same hypotenuse. So 39 in quadrant 2 is really what total angle?
109.
No, good guess. It's 39
119.
away
So it's
No.
is
from
it,
180.
well, okay,
Oh.
so it's yeah, okay.
Say it. How would you get it?
180 minus 39.
180 minus 39.
141.
141. 141. So it turns out that B could either be 39 degrees or it could be, what'd you say?
141.
141.
Oh, that's really
That
annoying.
yeah.
So on your calculator, do this. Do sine of 39. Go ahead. Do sine of 39.
I
You
got
get point
62.
59, right? Yeah. Now do sine of 141.
0.62.
Same thing.
Oh my god.
So in other words, we have to acknowledge that could be the big angle being in the first quadrant, this 39 degree one, or it could be the big angle that has the same result. It's like sine of some angle is this 0.62, and the two angles that it could be are 39 and 141. And we ask ourselves, if B was 141, I'll put in the 141 here, and you ask yourself, so it's no longer the case 113. If I put in 141, do I have enough space for angle C to, is this less than 180 such that I
Yeah.
can, it is. Therefore, there are two answers to this triangle.
That is not.
This
okay.
Do
is,
they always ask for like
This
both?
is a myth.
good job, good job.
They do.
So they'll say, state whether, good, like you're recognizing the scope of the problem. So you put your hang your head forward like this, recognizing the scope of the problem. The scope of the problem is, the problem may say, state whether there is one or two triangles. If the 141 that we created can add with the given information of 28 and still make room for a third angle, then there is a second triangle. What is that third angle, please? Can you get it?
Yeah.
What is it?
It is 11.
11. So just barely. We just made it. So in other words, if we could have angle A, B, C, CC. CC me on these emails.
BC.
Well, but yeah, BCC me. I'm not allowed to carry an iPhone for security reasons. All right. So given information was 28. We got the new angle at 141, and you said this was 11.
Yeah.
Given information was still 3. Given information was still 4. See, we honor the fact that A and B are still 3 and 4. And now we have to solve
For C.
for the new C using Law of Cosines, which we won't necessarily go through right now because you could if you needed to. All right? Maybe we can do the setup just for practice. Want to do the setup for practice?
Yeah.
Let's do it.
Let's do the setup. It would be sine of what angle?
C. Wait.
Which we know is
11.
11.
So sine 11
over
over C.
C equals sine of what over what?
Sine.
Given information is the
B
best.
Or A.
Let's do the one we were given.
Sine 28.
Sine 28.
Over 3.
Yeah. And that would be the way to get the last part of the second triangle. Isn't that crazy?
Yeah.
It's crazy.
annoying.
Yeah, it is. I get what you're saying, but it's only applicable if you have this. Okay? Only applicable if you have that. And so there may be two triangles, which we just
But you
said.
never know
applicable if you
until
have-
you actually do it.
You never know until you do it,
that's
right? If you're given this situation, you have to say, I'm given two sides and an angle not between, which we're going to do next. And then you're going to say, okay, well, can we make a second triangle? If you can't, you just stop.
So if it was ASA, then you don't.
Then you don't need to do it, right? Because there's only one triangle you can create. That's the right question. If I gave you ASA, in other words, let's say I gave you a side, this thing, right? If I gave you like a stick that was 5 inches, and I said the angles around them are locked, meaning I gave you this angle, and I gave you this angle. Wouldn't that lock the triangle into one triangle?
Yeah.
Yes.
It would. It would.
Oh, I see.
So there's no ambiguity there. Okay? So if this is the side I gave you, and this angle is set, has to be 30 degrees.
Oh, I
Boom.
see, I see.
This angle has to be 40 degrees. Boom. Let's say that's only one triangle you can create. But this, you could create multiple triangles. Okay? Let's see if you could spot the ambiguous case with the next one. By the way, super awesome thing to share with you. The books teach this in a way that I reject. I reject the way the books teach it because they don't do it conceptually with sine. They do a whole bunch of formulas that make no sense. So you end up memorizing. You'll notice you memorized nothing here. The only thing you acknowledged is if B could be something else. If B could be something else, either 39 or 141. Okay? And you'll see how well that sticks on this next problem. All right, once you draw that down, then ask yourself, is this an ambiguous case? Meaning, are there two sides given and an angle not between them?
Yes.
It is. So potentially, you could have one triangle, you could have two triangles. Let's go ahead and solve, because we're gonna see, the process always starts the same. Sine of
124.
124 over
30.
30 equals sine of
B. C.
either one.
C.
Well, actually, not either one. It should be C, right?
Yeah.
Because we have the 22.
Yeah.
Sine C.
Sine C over
22.
22. Cross multiply and solve.
So,
We get
okay.
sine C equals. Solve on a 30 sine C equals 22 sine 124 over 30 over 30. Gone. Sine C equals. Oh, write it down lower.
Wait.
What's this ratio?
I got it's
Point.
yeah, I got 0.55.
0.55. Can you have a few more? 5 what?
26.
26. All right. So let's get what the angle C needs to be as a result using inverse trig. So C equals
Sine.
inverse sine
Negative 1.
0.5526. On and on and on. And what do we get?
33.4.
33.5. Let's do it. 33.5. Okay. So that would be 33.5 would go here. Okay. And would you be able to solve the rest of the triangle using law of sines?
Yeah.
You would get this, which would be how many degrees? Go ahead. You can get it. Using 124.
4 minus 50.5. It'd be 22.5.
22.5?
Yeah.
Sounds right. 22.5, and you would get side C using law of sines as well, or side B, excuse me, using law of sines. Okay, let's check ambiguous case. So we said sine of C, or C was 33.5. Let's get our little triangle going. Here's your 33.5. Opposite hypotenuse. Where else would I draw this triangle? What quadrant?
2.
2.
Those.
What would this angle be? Reference angle?
33.5.
33.5 indeed. Is this still O?
Yeah,
Still
dog.
H. Okay, and now you're asking how many degrees is that, right?
One. What? I got like 146.5.
0.5, that's right, because you did 180 minus 33.5. So 146.5. 146.5. And that was in place of C.
Yeah.
146.5. Pause. Any questions about the fact that C could be either 33.5 or 146?
Hell nah.
Is that okay? Is that okay for you, Adam? Okay. Now the question is, let's take that off again. That was C. So 146. Is that possible to have a triangle with 124 and 146? No. So does a second triangle exist?
No.
No. One triangle only.
Sick.
Okay.
Yeah.
So you do your check. You see whether there could be room for the third angle. If there is room, then you should create a second triangle. If there's no room, like in this case, you have only one triangle to solve, which we said was 33.5, one in there. You said, what was it? It was 20 something. What was this? The one.
It was 22.5.
Thank you. 22.5 goes there, and then you'd solve for B using law of sines, and that's one triangle. Okay. All right. So great. That was either one triangle or two triangles. Very nice. Let's do one more ambiguous case.
Do it.
One more. Last problem. Law of sines crushes people around the country, I'm telling you. People are uncomfortable with the law of sines because they can't wrap their heads around the ambiguous case.
Fear no more people around the nation.
Obama.
For
man.
or
Feel no more.
ObaMATH.
So true. Fear no more.
Fix your life.
Yeah. Okay, let's draw. So what they'll do is they'll say solve the triangle, and they won't even draw it sometimes. So what we need to do is draw it ourselves. So we can just draw any triangle. Preferably we could see A is 120. Can we draw an obtuse then? Let's do it. Let's draw an obtuse. There you go. Obtuse triangle like this. Here's A, B, C. And we'll put in our given information. 120. Where would the 10 go?
It would
across
go
from it.
hypotenuse.
It looks like the hypotenuse, but I would say across from a 120. Is that okay? Because side A is across from angle A. Makes sense? Where would the 19 go?
It would be across from B.
It would.
At the bottom.
19. Very nice. All right. Let's do Law of Sines
Yeah.
and try to solve this problem. Sine of. Give me an angle.
120.
Yeah.
120. Over
10.
10.
10 equals sine of what angle?
B.
B.
B. We have to use B because
Oh,
it's side
yeah.
B, right? Over, side.
19.
19. Cross multiply.
So,
So we get, yeah, let's do it. 10 sine B equals 19 sine 120. Divide both sides by 10.
oh Lord.
Yeah, exactly. Good job. Yeah. Did you hit the wall? Did you hit
Yeah.
the wall? That was what I wanted.
19.
I got like
3 over
19.
20.
Yeah. It's on my calculator, Dylan.
This thing?
Yeah.
So sine B equals what?
So I got like sine B equals 19 root 3 over 20.
Okay, it's a decimal. Let's get the decimal version. Hit that. Give us 19 sine 120
19,
sine 120 over 10.
19 sine 120
Yeah.
divided by 10.
Yeah. Get
0.64.
0.64?
1.64.
Oh, 1.64. Ba, 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 ba. All right, sine of B equals. So now we're going to do inverse sine.
Yeah, that.
Yeah.
Yeah, that
I was about to
thing.
say inverse operations.
Inverse operations is true. All right, do the inverse sine of 1.64 and you get?
It's a domain error, so
Inverse sine of 1.64.
there must have a 0 on the bottom.
That
or something.
is domain
I'll
error.
explain in a second. There's no triangles that can be drawn. If I gave you, isn't it interesting? If I gave you a side that was 10, and I gave you a side that was 19, and I said the side across from 10 has to be 120, you couldn't make a triangle. It would look something like this maybe. Like you couldn't make one. It wouldn't close. And I'll tell you that. I'll tell you why right now. Actually, if you agree, this is an important rule. Actually, sine of an angle equals opposite over hypotenuse, which is always bigger, the opposite side or the hypotenuse.
The hypotenuse.
The hypotenuse is always bigger. So if the hypotenuse is always bigger, so this is small over big. Again, just see if you can understand this now. If you have a small number over a big number, what can you tell me about this fraction? It'll always be less than what number?
1.
Less than 1. Less than 1.
Oh, okay,
It'll
yeah.
have to be. It'll be like
Yeah.
5 over 6.
Yeah.
9 over 10.
9
9 over 20. Always.
So if I said like 180 over 181.
Fine.
Oh, okay.
Yeah, that could work. You could have an opposite side that's 180 and a hypotenuse that's 181.
It's a big triangle.
It's a large triangle, that's right, or 180 millimeters. It's small again, so it's all relative. But you can never have the bigger number on top, because if the bigger number was on top, this would be bigger than the hypotenuse. Not possible. See how sine can't result in a number more than 1? Do you make sense to you?
Yeah.
That's why you can't make a triangle. So, with the ambiguous case, there are 3 outcomes.
Oh, Lord.
How many triangles?
2.
2 triangles possible. Or how many triangles?
0.
No triangles possible. Or
3, 1.
how many
4.
triangles?
3.
What did we do today?
3.
Did we do one with 3 triangles as a solution?
No.
No.
How many?
1.
1 triangle.
Yeah.
one triangle.
Uno.
So the ambiguous case has 2 triangles possible, no triangle possible. Actually, I like to do this. Ha!
Good one.
You guys said I would be a comedian. Watch out. I'm coming on you. Bring it on, Fallon. And 1 triangle possible, which is the problem we did before this one. Okay? Did it make sense in the moment? In the moment, did it make sense?
Yeah.
What's good about this method, I'm telling you, just to try to, like, I guess, sell you on this method, which is better than other methods, we don't need to know that there's no triangle when you see the problem. Just start solving. And then if you hit the wall, just stop and say no triangle. That's it. That's all it is. Sine can't be point or 1 point something. The calculator didn't even let you go forward. So you're like, domain error. No triangle. I'm done. Okay? Okay. You guys are good.
Yeah.
We're burning the midnight oil here in the Oval Office. So I guess we'll say farewell. Awkward ending. Hit it. Hello, I'm President Barack Obama. In any approaching election season, it is of the utmost importance to vote. Your vote directly shapes the future of our nation. Simply Google how to register to vote for details in your area. I'm Barack Obama, and I approve this message.